Hello! Today, I want to show you another one of the wonderful functionalities we have available on our SICAM 8 automation units. I am talking about the possibility to configure redundant bay control units through IEC61850. Let's see how we can do it. The idea of the solution is as follows. There is redundant information coming from both bay control units. This includes, for example, positions of circuit breakers and also their commands. We will configure these information as if it were coming from both devices. Since we need that only one BCU sends information at a time to the SICAM 8 automation unit, we will block the communication to the BCU 2 whenever the BCU 1 is communicating properly with the SICAM 8. And whenever the communication between the SICAM 8 and the BCU 1 is not working properly, we will start the communication with the BCU 2. On each BCU, there is also information that is not redundant. This means there is information that belongs to each BCU. This is the case, for example, of the protection trips and pickups. This not redundant information must be available from each BCU at all times. How do we achieve all that? Well, to receive the redundant information, we will configure a protocol element which will be used exclusively for that. To receive the not redundant information, a second protocol element will be configured. The first step on the configuration is to equip the two required protocol elements with the ETI5 firmware used for IEC61850. One will be used to acquire the redundant information, and the other will be used to acquire the not redundant information. Both protocol elements will be assigned to the same LAN, so both will share the same physical port and IP address. Now, in order to integrate the information of the BCUs via IEC61850, we need to create an IEC61850 configuration file, also called SCD file. This we can do with the SICAM software included with DIGSI5. There we can assign an additional IEC104 information object address to each signal. We must assign to each redundant information a unique IEC104 information object address, regardless of it coming from the BCU1 or from the BCU2. In this way, while importing the configuration into SICAM Device Manager, the system can know that this is actually one information signal with two different sources. For the not redundant information, the signals must receive a different information object address if it is coming from the BCU1 or from the BCU2, so SICAM Device Manager can know that it must create an individual signal for each BCU. From SICAM, we can also export a CID file for each BCU. These files we can use later to import the redundant information into SICAM Device Manager. Now we can go to SICAM Device Manager to import the BCU for redundant information. We go to the IEC61850 box, and then we select the IEC61850 client box corresponding to the PRE we are using for redundant communication, which in this case is the PRE0. Now, we can click on the button to import the configuration file into SICAM Device Manager. Here we select the CID file corresponding to the BCU1. Now we mark it so the connection can be created. And now we select the information we want to import. It is important to select only the redundant information. The not redundant information must be deselected, since it will be imported into a different protocol element later. Now we can select the next button to confirm the creation of these signals. And now we can finish the importing of the redundant signals from the BCU1. We repeat now the process for the BCU2. We select the corresponding CID file. We mark the device so it will be created. And as done before, we select only the redundant information. You can see how the signals imported here are the already existing ones from the BCU1. We can now finish importing the redundant signals from the BCU2. Click on Next. And then we just click on the Finish button. Now we can check in the RTU settings how both connections have been created. we can go to RTU settings. And there we can see how the connections to both BCU have been created on the protocol element 0. We will now import the non-redundant signals from the BCU. Click the button of IEC61850. Choose the ETI5 client box for the PRE1 we will use to get the non-redundant information. And then we select the Import IEC61850 Client Data button on the upper right corner. Here, we can import the complete SCD file that contains both BCU, since we want to import from there only the non-redundant information, which belongs individually to each one. We now mark both devices so both can be imported into the protocol element, then we click on Next. We must now deselect all the information already imported in the PRE for redundant communication, so only the information we want to receive individually from each BCU remains selected. We click then on Next. And now we can finish importing the signals. We click on Next. And then on Finish. As previously done, we can now also verify on the RTU settings that the connections to both BCU have been performed in the corresponding PRE. So we click on RTU settings. And there you can find both connections defined on the corresponding PRE. Now we need to generate the indications to show if the BCU are communicating or not with the SICAM A8000. To do that, we go to the RTU signals box. To add the signals, we click on the Add Signals button. We set the new signals with a proper name indicating that it will show the communication failure of the corresponding BCU 1 and 2. Once the communication fault signals have been created, we must assign them to the processing unit, where the protocol elements we want to monitor are located. In this example, we assign them to the master processing end. The assignment is performed through the Assign button. And now we will assign them to the processing type protocol element return information message. Now we go to the Parameter tab and assign Station Failure as return information function and the protocol element and station number of each BCU. Now we will use the generated BAY1 BCU communication fault signal to block or unblock the communication on the protocol element used for redundant information to the BCU2. To achieve this, we make use of the protocol element control messages available for the ETI5 firmware. We need to configure two actions, one to occur when the COM fault is active and another to occur when the COM fault is inactive. Therefore, we map the communication fault signal twice to the master processing. Then, we assign for both entries the processing type protocol element control message. Finally, on the parameters of the protocol element control messages, we perform the following settings based on the parameters found in the SICAM 8 RTU manual, which you can see here. The BCU2, whose communication we want to start or to stop, is connected via the PRE0, Station 1. These we set in the parameters PRE-CM and Station. We define that when the COM fault signal drops, which happens when the BCU1 is communicating with the SICAM 8 unit, the BCU2 should stop communicating. The drop of the signal is marked here with the parameter edge PRE, which is set to negative edge. Therefore, we set the control function PRE parameter to 129, which as per the manual should stop the connection. Similarly, we define that when the COM fault signals appears, represented with the edge PRE parameter positive edge, the communication with the BCU2 should be started. Therefore, we set the control function PRE parameter to 128, which as per the manual should start the connection. Thanks for watching. If you like this video, be sure to scan the QR code and subscribe to our channels. Wish you have fun with the new functionality in SICAM 8.